Welcome. Today I'll be presenting the architectural project titled Nest of Light, a pavilion developed at the University of the Americas Puebla. This project represents the collaboration between a team of architects and engineers who set out to design a functional, expressive, and structurally coherent space. The objective of this project was to create a three-dimensional architectural model using MDF, balsa wood, pins, and battery paper. More than just a model, the intention was to explore how form, structure, and concept could come together to shape a small but meaningful piece of architecture. At one point in the process, the project changed directions, and that pushed us to rethink the design, specifically the roof. Instead of sticking to a normal flat or pitch roof, we wanted something unique, something that would immediately stand out, and that's how we ended up taking inspiration from the shape of a starfish. It is not a common form in architecture, but that's exactly why it gave the project its own personality. To make that shape possible, we designed three-dimensional triangular frames. These frames not only form the roof but also extend towards the sides, giving the pavilion a consistent structural look. On top of that, we added a lattice pattern. We alternated between triangular plywood panels and triangular lattice openings, creating a rhythm that lets in light while keeping the structure interesting. This pattern became one of the key elements that defines the character of the pavilion. The pavilion is meant to sit between the Humanities Building and Colegio Bernal on the UTLAP campus. It is an open space not too steep with a steepness of 80 centimeters, which made it perfect for placing a lightweight structure like this one. The pavilion is roughly 17 by 17 meters, enough to create a functional gathering space without overwhelming the surroundings. In the architectural plans, you can clearly see the pattern that we chose and how it fit into the roof system. You can also see the plywood panels used in the other surfaces, selected not only because they are strong, but because they can look clean and warm. The structural plan shows the cimbra, which is basically the temporary framework that supports the triangular pieces of the roof during construction. This drawing helps make sense of how everything fits together and how the roof gets its final geometry. Building the model took us about a month. The first step of the building process was to make the cimbra. The cimbra is made up of individual wooden pieces, starting with the pata de gallo, which help keep the polines from sinking into the ground. After that come the polines, which are wooden sticks that are 10 by 10 centimeters across. We follow it up with the vigas madrinas and the largueros, which are big beams that help support all of the weight and pass it down to the polines. And on top of that, we have the plywood pieces, which serve as the floor of the pavilion. After we finished building the cimbra, we began by experimenting with materials that would be used in the upper structure. At first, we tried using the same materials and methods that we implemented in the construction of the cimbra, but we quickly realized that the size of the wooden pieces were not feasible for a project of this size. Even though we had to repeat the cuts on the pieces many times, we finally made a structure that could stand up by itself. Seeing the structure rise piece by piece made the entire effort worth it. The final pavilion is made of 8 triangular roof pieces that come together at the center. The mix of lattice work and plywood gives the roof both structural and visual texture, making it feel light but solid at the same time. Inside, we added a central wall that helps divide the space into 3 areas: a small lounge, a kitchenette, and a table area meant for shared use. This allows the pavilion to function not just as a shelter, but as a simple, comfortable place where people can gather.